Hello everyone, I am Abhiraj Roshan and we are Cyber Cells, participating in the Thales Tech India Hackathon hosted by HackerEarth. Our project is called Generative AI-based Adaptive Cybersecurity System, which aims to provide real-time threat detection and behavior-based authentication for high-security environments like banking and government sectors. As a team leader and architect, I designed the system architecture. I worked on implementing the LSTM-based anomaly detection model, which identifies network traffic abnormalities in real time. This is anomaly detection file. Here we use an LSTM model to detect unusual patterns in network traffic. The data is pre-processed, scaled, and structured into time steps, making it ready for anomaly detection. In this section, the LSTM model is defined and trained to predict normal network behavior. We then calculate reconstruction errors to identify anomalies like DDoS attack or suspicious login attempts. As you can see, anomalies are detected based on a threshold and flagged for further analysis. Now moving on the F file. This file connects the anomaly detection system to a real-time dashboard. The dashboard fetches detected threats from a database and displays them dynamically. This enables security teams to visualize and respond to threats quickly. Here, for instance, we define the database schema for storing threats, including details like time, type, and severity. This section handles the rendering for the dashboard, where detected threats are displayed for real-time monitoring. Additionally, there is an API endpoint that provides threat data for integration with other tools. Now, let me hand it over to Apurva, our network and database specialist, who will explain his contribution.
Hi, I'm Apurva Labde and I work on the network and database integration for this project. My role involved implementing a system to manage and integrate threat data, ensuring real-time monitoring and shameless update in the dashboard. I focus on a building threat data management system using SQLite to store real-time threat data. This database plays a crucial role in logging detected threat which can access the later for further analysis. Let me show you code for this part. This script is responsible for setting up database schema. It defines structure of database. This script handles inserting detected threats into database in real time. For example, when a threats like phishing or malware is detected, the data is immediately saved to database for further action. These files ensure system has a reliable backend for managing threat data. I also work on integrating this database into a real-time dashboard, making it easy for security team to monitor and respond to threats. Here is a code for this dashboard. The Flash framework fetches data from dashboard and dynamically update the dashboard. This ensured that system displays up-to-date information about threads in an easy-to-understand format, helping administrator take action. This was my part of the project focusing on a database integration and dashboard functionality. The adaptive authentication mechanism also add an extra layer of security. Now I will handle it over to Himanshi Pant, our AI integration and backend lead, to explain her work on the AI models. Thank you.
Hello everyone, my name is Himanshi Pant and I was responsible for integrating the phishing and malware detection modules into our system. I have also implemented the machine learning models using random forest classifier to detect phishing and malware. I have trained these models on phishing and malware datasets to ensure they can classify malicious activity accurately. So, as you can see in this code basically implements the phishing detection. In this file, I have trained the random forest classifier to identify phishing emails and malware based on their features like keywords, links, and patterns. For backend scalability, I have introduced this file named models. I have ensured that the system is scalable and can handle large volumes of incoming data without performance issues. The backend integrates seamlessly with the anomaly detection and phishing or malware models to provide quick responses. So, now let's move forward with Mehak Kalia, our cybersecurity and full stack lead, to explain the cybersecurity logic and real time threat monitoring. Thank you.
Hello everyone, I am Mehak Kalia and I have developed the cybersecurity logic and real-time monitoring system for the project. So, like majorly my task was to develop the cybersecurity logic in the project, like the adaptive authentication module, which processes out how exactly the cybersecurity logic is being built. So, uh, taking the case study as I could be showing one of the file in the code itself. So in the adaptive authentication.py module, we can see we are authenticating the user on the based of the human control of the average typing speed of the person or the user. So its process follows as follows. We take the average baseline user behavior of 200 and receive the current input and compare the baseline to the average the input and calculate the absolute value, and on basis of that we grant the user access to the user, whether if the user is authenticated or the authentication is required. So I had developed similar of the cases in which we are taking the original human behavior to a robotic behavior, like if the project is a threat or like it is a usual human behavior. And apart from this, I had created the dashboard of the real-time threat monitoring dashboard, which basically detects all the anomalies that are being detected, and it shows that exactly what is happening. In the dashboard it shows like we had received a phishing attack on today at 12 p.m., and then a malware which is a medium attack at 5/11/2024, around this particular time. So this is what my major task was in the project itself. So next we would be hearing from Sneha Mondal, who designed the dashboard and served us as the quality assurance expert for all the code we have written in this particular project. Thank you.
Hello everybody, I am Sneha Mande and I contributed by creating the UI UX of the threat intelligence detection dashboard, which is a very convenient and user friendly way of showing the potential threats to the user regarding what we have detected. So as I proceed towards showing you the code part, so this is the basic HTML framework of the threat intelligence detection dashboard, where we are getting the data from our Python AI models, and we are just showing the threat type and the severity of the threat, how much severe it is. So in the backend, what is actually functioning is that we are particularly having three modules: the phishing detection module, anomaly detection module, as well as adaptive user testing. So based on the output what we are getting on, based on all the three threat detection factors, we are determining whether the application is having a threat or not. So I will just give a brief overview of each of the module. We are comprising mainly checking three factors: anomaly detection and phishing detection. So in anomaly, we are performing basic using LSTM model. We are collecting the data, performing essential feature engineering, and using our LSTM model, we are monitoring whether there is anomaly or not. Similar to the phishing and manual detection module, we are collecting the data, doing the particular pre-processing, and using random forest model, we are checking whether the data is, means whether it is a phishing or malware site or not. In similar manner, in the adaptive user detection phase, what we are doing is that we are checking particular user keystrokes to determine whether it is an anomalous user or not. So regarding the overall functioning of the our project, as well as its integration with the UI UX interface. So as I have already told, we are having three modules. So if we follow this flowchart, first we are executing the anomaly detection module, which is if there is an anomaly, it is flagging the anomaly, otherwise it is marking and save. Then we are proceeding towards the phishing and malware detection module, where again, if it is a phishing and malware is something detected, then we flag it, otherwise we finally go to the adaptive user method or adaptive authentication, when we check the suspected user behavior, and the criteria for that is number of keystrokes. So if it is below or above a particular threshold, we are flagging it, and then we are based on all the three checks, we are logging, we are getting the data from our backend. Our models are deployed on the backend, we are running them, we are getting the results, and then we are integrating the results in our UI UX website, as I have showed in the code: the threat type, the threat severity, and the threat time, what time we are detecting the threat. Now I will proceed towards elaborating few points regarding the key outcomes. So the key outcomes what we are definitely getting is that high detection accuracy. We have tested our models, we have trained them, and the system is very effective. Real time threat detection, we are detecting it at real time using the user behavior, as I already described, as well as adaptive security. Based on the user behavior, we can adapt whether it is secure or not. So it is a form of adaptive, and in future we can add many functionalities like online learning models, cloud integration, SIEM integration, and user feedback. Apart from that, the unit and integration testing of each of the three modules, as I have explained, has also been performed to ensure that the model is being tested properly. Training and testing the models of all the three modules, the phishing module, the anomaly detection, and the user authentication module, all the testing has been done, and hence we are able to integrate all the three modules with the UI UX to finally display the data. Now I would request my friend Aviraj Roshan to continue and give a overall working demo of the model and of the project. Thank you so much.
Let's begin the real-time dashboard of our generative AI-based adaptive cybersecurity system. As you can see, the dashboard displays categorized threats with detail like time, threat type, and severity. This helps security teams monitor and act on alert in real time. Now let me show you how this data is stored in our database. I will open the database in database browser for SQLite. Here you can see how the threads detected by the system are stored. Each thread is logged with its time step, type, and severity, providing a clear record for analysis. Let me show you the Python script responsible for inserting and managing this data. This is a script we use to initialize the database and add some sample data. It clears existing data, creates the required schema, and insert new threads. Using this script, we have inserted sample threads like phishing and malware for demo purpose. This ensures the dashboard always has data to display. Now let's see how the system dynamically detects and logs threats. Finally, I run the F file. This Flask application connects the database to the dashboard, enabling real-time updates. The system uses an API endpoint to fetch threat data and display it on dashboard. This ensures seamless real-time monitoring. Like you can see, threat intelligence dashboard. To summarize, our generative AI-based adaptive cybersecurity system offers real-time threat detection and adaptive authentication for sensitive environments. By combining a robust LSTM model and dynamic dashboard integration, it ensures proactive security management. Thank you for watching, and I look forward to your feedback.